All right, we're going to go in number order of the practice midterm, so make sure you watch the numbers that you need the most help on. Number 1, we're taking the square root of 49 over 9. Now, if you try to divide 49 divided by 9, you get something messy. So what we can do is we can change that to the square root. Hold on. We can change that to the square root of 49 over the square root of 9. So now we have the square root of 49 in the numerator, square root of 9 in the denominator. That makes things a little bit more simple because we do know the square root of 49 is 7 and the square root of 9 is 3. So our answer is just 7/3. Now in number 2, we are taking the cube root of -8. So square root means what number can we multiply by itself twice to get the number? So like 7 times 7 is 49, or 3 times 3 is 9. But here we're wondering what number can you multiply by 3 times by itself to get -8. So it's going to be a small number if we're multiplying it 3 times, right? 3 times 3 is 9, and that's only twice. So 3 times 3 times 3 is 27. So without a calculator, then we would try 2 next. 2 times 2 is 4, times 2 is 8. So positive 2 is the cube root of 8. So since this is the cube root of -8, it's -2. -2 times -2 times -2 is -8. Now for number 3, we're actually evaluating an expression. So I would start with the square root signs. That's like your exponents if we're doing order of operations. So the square root of 16 is 4. Now there's no operation symbol there. It's just 4 square root of 16. If there's no operation symbol there, it's multiplication. So that's not 4 plus 4. That's not 4 minus 4. This is 4 times 4. All right, and then looking over here, the square root of 25, that's 5. So we have 4 times 4 minus 5. Make sure, again, you use order of operations. So we do 4 times 4 first. 16 minus 5 is 11. So our final answer here is 11. Number 4, we have the cube root of 64 cubed. Now you can think through this answer all the way out. If the cube root of 64 is 4, because 4 times 4 times 4 is 64. So the cube root of 64 is 4. Now if we take 4 cubed, that's 4 times 4 times 4. We're back where we started. So a cube root cancels out with a cube. So this is just 64 and then plus 3. So our answer here is 67. All right, on 5 and 6, we're finding a missing side length. These are both right triangles, so if we are missing a side length of a right triangle, we use the Pythagorean theorem. That's one thing you're going to have memorized for this Part B midterm. So the Pythagorean theorem is a squared plus b squared equals c squared. Remember that the c is the only special of the 3 out of a, b, and c. C stands for hypotenuse. The hypotenuse has to be the side that is across from your 90-degree angle. So in this case, our hypotenuse is 17. So c stands for the longest side. So c squared. Now it doesn't matter which side you decide to make a and which one you decide to make or which one's A and which one's B. So I'll just plug in 8 for B. And that means we're going to look for A. So A and B you can switch up and on, but C has to be your hypotenuse. So we have A squared plus 64. 17 squared, you can do that math, probably out to the side. You should have gotten 289. Then we subtract 64. So A squared is 225. To get A all the way by itself, to get rid of that squared, now we take the square root of both sides. The square root of 225 is 15, so that's how we got the answer for this side length as 15. Now, I know that you might not have known this off the top of your head. The one on the midterm you will be able to know, or at least find really easily. So 6 is the same idea. This time your hypotenuse is x though. And again, it doesn't matter which one's A and which one's B. We'll just do 3 squared plus 4 squared equals x squared. Don't forget to square your sides. So 3 squared is 9, 4 squared is 16. If we add 9 and 16, we get 25. So see, this one's a lot simpler, smaller numbers than the last one. So if 25 equals x squared, if we take the square root of both sides, then x equals 5. All right, 7 was a longer problem. I'm trying to get that gross spot on the way, but you've got your paper. This is 0, 0, and 8, 3. This one's longer because the distance formula is a long formula. You do need to have memorized the distance formula. So distance equals x1 minus x2 squared plus y1 minus y2 squared. And then we take the square root of all that. So it doesn't matter which x you use first and which one second. Oh, what am I doing? So this is xy, xy. So we're going to take x minus x. I like doing the 8 first, so we'll do 8 minus 0. So 8 minus 0 squared plus 3 minus 0 squared. So 8 minus 0 is 8. 8 squared, that's 64. 3 minus 0 is 3. We're going to square it, that's 9. So I have 64 plus 9. That's going to give us 73. There is no perfect square, so we would just write the square root of 73. Now, if it did ask to round it to the nearest whole number or round it to the nearest tenth, let's talk about how to do that with number 8. So remember, if we want to round a square root sign to a square root of a number to the nearest whole number without a calculator, we need to think of a perfect square that comes before the square root of 27 and a perfect square that comes after the square root of 27. So we have the square root of 25, which is 5, and the square root of 36, which is 6. So these two numbers should be consecutive. They should be right next to each other. And then we decide which one of these is closer to 27, 25 or 36. The answer is 25. So that means that square root of 27 is closest to 5 than any other number. So on the whole number line, you would write 5. Now, it also says to the nearest tenth. Well, if we know the square root of 27 is the closest to 5, that means it's either going to be 5.1, 5.2, 5.3, 5.4, or maybe 5.5 if we have to go there. But I am saying 27 is pretty close to 25, so I'm going to start with 5.1 and 5.2. All right, so what you would need to do is we're going to square both of these and see which one's closer to 27. If neither one of them are very close, then we'll try 5.3. So let's try 5.1 first. 5.1 times 5.1. So you might have done your multiplication differently, and that's okay. So let's see, we get 1, all right. So 2601 is what I got. So 26, not so close to 27. So let's try 5.2. So 5.2 times 5.2, let's see if we can get closer. 26, 4, 0, 7, 2. All right, here I got 27.04. So that's pretty stinking close. So, and it went over 27, so we know 5.3 is not going to be any closer. So 5.2 is the closest tenth to the square root of 27. All right, now 9 doesn't really show up all the way, so hold on a sec. Okay, so numbers can fit into multiple categories. So let's talk about the different categories. Natural numbers. Remember, it is natural to start counting with the number 1. So natural numbers are 1, 2, 3, 4, and on and on and on. Whole numbers. Whole numbers are all your natural numbers, but it includes one more, and that is 0. And I remember it because 0 looks like a whole. So whole numbers are 0, 1, 2, 3, 4, and on and on and on. So now that we've got a 0 included, now we've got to include our negative numbers. So your integers are all your negative whole numbers, basically. So like -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, 5, and on and on and on, and so forth. So any number that doesn't have a decimal or a fraction, basically, would be an integer. So all your negatives and positives without extras. All right, so if it's an integer, it's also a whole number and it's also natural. If it's a whole number, it's also natural. I just said that all wrong. Scratch that. If it's a natural number, it also fits into the whole number category because we're just adding 0 to get there. And if it's natural, it also fits into the integer category because The integers are all the whole numbers, natural numbers, plus the negatives. So not all integers are natural numbers because a negative number is not natural, but all natural are integers. All right, now rational starts including our fractions, decimals that repeat, anything that can be turned into a fraction we would consider a rational number. How I think of it is rational is anything that's not irrational. And your irrational only includes numbers that have pi and any square root that does not come out even. So like the square root of 27, like we just did. It doesn't come out even, so that would be irrational. So if it's not irrational, it's rational. That's how I think about rational. But any natural number is also rational. Any whole number is also rational. Any integer is also rational. But this is where we draw the line. If it's any of these categories, it cannot be in this one. And if it's in this one, it cannot be in any of these. So now let's go through this list. Square root of 25. Well, that does come out even. That's 5. And 5 is a counting number, because if I say how many students are in this class, you would start counting 1, 2, 3, 4, 5. So 5 is natural. And if it's natural, it also has to be whole, integer, and rational. So you would mark all of those categories. All right, now this one has a pi. Well, today's pi day. Well, not for you, for me. And so we know that pi never ends. It never repeats itself. So that's an irrational number. It's one of our two that we need to remember. So we would mark irrational. And if it's irrational, it can't fit into any others. Now for negative 11. Well, negative 11 we don't count with negatives. So it's not a natural number. It's not a whole number, because whole number is just your natural plus 0. So it's an integer, because now integers start including negative numbers. And if it's an integer, it also has to fit in rational. But if it's rational, it can't be irrational. All right, last one, 15 over 4. So this is a fraction. Can we take 15 over 4 and get a nice clean number? No. So it's not natural if it doesn't come out clean, because we don't count with that number. It's not whole, because it's not clean and it's not 0. It's not an integer, because integers also have to be clean, but they also include negatives. So it must be rational, because it's a fraction, and it's not irrational if it's rational. Okay, we'll just do 2 more on this video. So on numbers 10 and 11, you have to decide if they're adjacent or vertical, and then you have to decide what x is. Adjacent means next to, and vertical angles are across from. That's when we have an x. They're the angles that are opposite of each other, if that makes sense, or over here and down here. I guess I could draw that. So vertical are if they are across from each other. Adjacent means they're right next to each other, and they also have to share a side. So for number 10, they're adjacent because they're next to each other. They share this side. So we would write adjacent. Now, this box means that together these two angles add up to 90 degrees. So if this one's 61 degrees, to find x, we would take 90 minus 61, and that's how we get 29 degrees for x. Now 11, these are vertical angles because they're across from each other. If we did x and this angle next to x, those would be adjacent because they share this side, but if they're straight across, they're vertical. And so you would write vertical over here. And then since they're vertical, the special thing about vertical angles is they are also congruent. So if this one's 48 degrees, so is x.